welcome to the stage Michael Johnston of Qbox.io.
Hello, everybody. My name is Mike Johnston. I'm with Qbox. I'm a senior infrastructure engineer and co-creator of Supergiant, which is an open source Kubernetes management platform. My presentation, Zombie Kubernetes, is a public service announcement of sorts to persuade you to use immutable infrastructure with your Kubernetes deployments if you aren't already. So I bet you've often sat around wondering, why don't I have my own personal army of zombies? Also, what is immutable infrastructure? Well, I'm here to help answer at least one of those questions. So I'm not going to assume that everyone knows this, but I'm going to start with the basics. Immutable infrastructure is the process by which whenever you want to update a server configuration in your fleet, you do so by creating a new configuration, applying that new configuration to a new server, and actually destroying the old server in the process. Now, this is different in the sense that traditionally you would update that server in place. Kind of like a horde of zombies rising from the dead. So many of you may sit back and think, well, of course, this is a no-brainer. I already do this. But I've been struck by the number of Kubernetes users over the last year that have no idea what immutable infrastructure is in the first place, or cling to old provisioning methods when setting up their clusters. Don't get me wrong, older provisioning tools are great, but when you're dealing with an infrastructure that's ephemeral in nature to begin with, its overhead like complexity, points of failure, possible security holes that you really want to try to avoid. It's not going. There we go. So if you're using containers already, you already are using immutable concepts. Containers are immutable by nature. If your container scope is or should be well defined by its function. When you update a container, you put that new container out there, replacing the old container. So how do I apply this type of thinking to my Kubernetes cluster? Well, first, you could leverage something like user data, cloud config, anything like that. You could use pre-built images, something like AMIs. Provisioning your cluster in this way has the benefit of being typically much faster than using older provisioning methods. The faster that we can get nodes to boot underneath our Kubernetes cluster, the more agile that Kubernetes cluster is when faced with hardware failure, or in the case that we need to upsize or downsize that cluster. Even a few minutes in savings in your provisioning process can help make your application more agile. So what do we need for a declarative node configuration? Well, obviously, you need to have a kubelet in your configuration, something like your kube proxy, maybe Docker configuration, and any networking configuration. The idea here is to keep things simple. So what happens if any of these processes actually fail? Well, in that case, we kill the node. We replace it. Your infrastructure at that point comes back to life from the dead. And I typically use stuff like health checking tools built into either load balancers or home-rolled health checking tools to check the health of every individual component of my Kubernetes cluster. If any one of those components has a failure, I kill the node and replace it with a healthy one. So what about your Kubernetes masters? Well, it can be a little bit more complicated to configure Kubernetes masters in this way, but especially if your etcd cluster is separated off onto its onto its own cluster is totally doable. Again, this is just achieved by taking the basic components of your Kubernetes master, placing them in a predefined configuration, putting some type of process in place to check the health of all of those components, and take care of any misbehaving nodes. And a huge caveat to this, obviously, would be if you're running a single node master, which if you were running that in production, shame on you. You should be running a HA setup for your master. So in conclusion, immutable concepts will help reduce complexity in your overall infrastructure, enhance speed and reliability of failover, and also increase application responsiveness within your infrastructure. So that's it from me. I'm Mike Johnston from Qbox. I'm a senior infrastructure engineer. Our business is hosting Elasticsearch for our clients. We've put these practices in production with our business for well over a year now, and the results have been amazing. If you have any questions, I'll be available after the talk and throughout the week at the conference. So thank you very much.